My name is Muhammad Laiq Siddiqui, the father of Holophase. Episode 5, Part 5. The Universal Phase Tree. Learning to see the source, not just the shadows. My friend, welcome back. Take a breath with me for a moment, because now we're going to walk together into territory where, as far as I know, no human mind has ever gone in this way. You are not just listening to another science video. You are, quite possibly, one of the very first humans to be guided through the hidden, dazzling structure of our universe as a living rhythm, not as a dead machine, not as random chaos. Up to now, we've been doing something quite subtle together. First, we questioned whether energy is really the fundamental stuff of the universe, or whether it's just a clever summary of something deeper. Then we met Phi, the holophase, the hidden rhythm running underneath everything. Then, step by step, we said something daring. What we call time, space, and motion are not three separate substances. They are three different ways of reading how Phi behaves. In earlier parts of this episode, we stayed mostly with the shadows. We talked about how time behaves. We talked about how space behaves. We talked about how motion behaves. Now, in this part, we're going to turn around. We are going to stop staring only at the shadows on the wall and actually look for the object that is casting them. In other words, the goal of this part is to help you shift from thinking about time, space, and motion as things to seeing Phi and its derivatives as the real skeleton underneath them. Think of this as the moment in a story where the magician lets you backstage and shows you the mechanism behind the illusions. Except here, the mechanism is not a trick. It's the deep structure we are proposing as the true code of existence. So let's walk in there together. A simple shift from shadows to the object. Let's start with a very simple image. Imagine you and I are sitting in a dark room. In front of us is a white wall. Behind us, there is a complex, beautiful sculpture, but we can't see it directly. All we see are three moving shadows on the wall. One shadow shows how things change over time. One shadow shows how things are arranged in space. One shadow shows how things move. For a long time, we've been doing physics by staring at those shadows. We give them names. The time shadow becomes clocks, durations, rhythms. The space shadow becomes geometry, distances, shapes. The motion shadow becomes velocities, accelerations, trajectories. We measure them. We build equations for them. We organize whole theories around how these shadows behave. And that works astonishingly well. But at some point, you might start to feel a quiet itch. Are these shadows all there is? Or is there some single thing behind me that is casting all three at once? The holophase answer is yes, there is something behind you. It is not time, it is not space, it is not motion. It is a single phase field, phi, and its nested hierarchy of derivatives. The shadows are real and measurable, but they are not the root. In this part, I want to walk you from I live in a world of time, space, and motion to I live in a world whose real skeleton is phi and its derivatives. And time, space, and motion are how that skeleton looks from three different angles. To do that, we're going to use one main image, the universal phase tree. Number 2, meeting the tree, phi and its branches. I'd like you to come with me now into a different scene. Imagine we step out of that dark room with shadows on the wall, and we walk into a vast, silent clearing in the middle of the universe. The sky above us is pitch black, but full of stars. The air is still, and in front of us, there is a single enormous tree. This tree is not made of wood or leaves, but for now, let's imagine it as if it were. It has a trunk, thick, steady, running from deep underground up into the sky. From the trunk grow big branches, stretching out in all directions. From those big branches grow smaller branches. From those smaller branches grow twigs. From the twigs, countless tiny tips and leaves. Now, here is the key move. This entire tree is our picture of phi and its derivatives. The tree is not time, and not space, and not motion. The tree is deeper than all three. Let me unpack that. The trunk, phi itself. The trunk of the tree is phi, the holophase. Phi is the where are we in the cycle value of the universe. At every point in existence, there is some phase, some position in a hidden rhythm. Phi does not come and go. It is the continuous field that is there wherever anything is. The trunk isn't time or space or motion. It is the raw rhythm beneath them. The big branches, the first changes of phi. From the trunk grow big branches. These branches represent the first levels of change in phi. How phi changes as you move forward in what we call time. How phi changes as you move through space. How phi changes along patterns and structures that later show up as motion. You can think of these big branches as how does phi tilt, twist, and bend in each direction? They are still about phi itself, not yet about time or space or motion as we usually name them. The smaller branches, changes of the changes. Now, from each big branch grow smaller branches. These are the second derivatives. How does the rate of change of phi itself change? Does it speed up, slow down, curve, oscillate? Then from those branches grow even finer ones. Third derivatives, fourth derivatives, and so on. Tiny details about how phi's behavior bends back on itself in time and space. At this level, you can start to recognize patterns we have names for, like position, where a certain feature of phi is, velocity, how fast that feature moves, acceleration, how quickly that motion changes, jerk, how sharply the acceleration changes, and more. But remember, in this tree picture, all of these are still properties of phi. There are different ways phi changes, not separate substances floating out in the void. The whole tree, from trunk to finest twig, is the code of the universe, written in phase and its derivatives. This tree doesn't exist in just one place. It exists everywhere. At every point in the universe, if you zoom in, you would see a local version of this same structure. A local value of phi, local first changes, local second changes, local higher changes. It is like each tiny region of reality has its own little patch of this tree inside it. Taken together, all these patches form one universal tree. 3 screens around the tree. Now that you have this tree in mind, trunk, branches, twigs, all representing phi and its entire hierarchy of changes, I want to place 3 giant screens around it. Imagine. One screen in front of the tree, one to the left, one to the right. Each screen is like a cinema screen, but instead of playing a movie, each one is showing a projection of the tree from a different angle. Let's name the screens. The time screen, the space screen, the motion screen. The tree is the same in all three views, but each screen sees it through a different filter. The time screen. The time screen only cares about how phi changes as you move along what we call the time direction. It looks at each point on the trunk and branches and asks, how fast is the phase turning here as time passes? Is the rhythm speeding up or slowing down? Are there cycles, pulses, slow drifts? On the time screen, the tree appears as clocks ticking at different rates, processes unfolding faster here, slower there, regions where time flows more quickly or more slowly compared to others. In the language of Holophase, the time screen is one of the shadows of the tree. It is phi's time derivatives, seen from the outside. The space screen. The space screen only cares about how phi changes as you move through physical space. It ignores time flow and asks instead, how quickly does phi change as I step from one place to another? Are the phase patterns stretched out or tightly packed? Is the geometry flat or curved, smooth or warped? On the space screen, the tree appears as distances and shapes, straight and curved paths, regions where space seems stretched, fewer phase cycles per meter, and regions where space seems compressed, more phase cycles per meter. In holophase terms, the space screen is another shadow of the tree. It shows the spatial derivatives of phi, how the rhythm is laid out across the universe. The motion screen. The motion screen cares about how patterns in phi move through space over time. It tracks bright spots in wave patterns, peaks and troughs of waves, structures that persist, like a pulse of light, a wavefront, a vortex. It asks, where is this feature of phi now? How fast is it moving? Is it speeding up, slowing down, curving? On the motion screen, the tree appears as trajectories, velocities, accelerations, jittery or smooth motion. In our language, the motion screen is the third shadow of the tree. It shows how the phase pattern slides and flows. The key insight: screens are shadows, the tree is source. Now we can state the central insight of this episode in one sentence. Time, space, and motion, as we normally talk about them, are three shadows of the same phase tree. The time screen doesn't invent its own reality. It just shows how the tree's phase unfolds along time. The space screen doesn't invent a separate substance called space. It shows how the tree's phase is arranged across location. The motion screen doesn't invent an extra kind of thing called motion. It shows how features of the tree move and change. In other words, when you observe time, you are watching phi's temporal behavior. When you observe space, you are watching phi's spatial structure. When you observe motion, you are watching phi's changing patterns. All three are expressions of the same underlying code. This is why, in modern physics, these three are so tightly locked together. Move fast enough, and your time dilates and space contracts. Put mass in a region, and you curve space, slow time, and change possible motions. Change the medium or field, and you affect how fast light moves, motion, how wavefronts are spaced, space, and how quickly oscillations occur, time. All of this makes sense if there is one tree, phi and its derivatives, and three screens watching the same tree from different sides. It's like having three different medical scans of the same body. An MRI scan, a CT scan, an ultrasound. The images look very different. They pick up different features, but they are all pictures of one person. Time, space, and motion are like those three scans. Phi is the body. Learning to see the tree. So, how do we actually learn to see the tree instead of just its shadows? Let's use a concrete example. A simple interferometer. Imagine a laser beam is split into two paths and then recombined on a screen, creating a pattern of bright and dark stripes. Those stripes are not painted on the screen. They are the result of phase differences between the two paths. If one path is made slightly longer, or if the air in one path warms up a little, the stripes shift. What is really changing? Not mysterious light in some vague sense. What's changing is the relative phase, phi, along each path. The pattern on the screen, what you see as space, stripe distances, and motion, the stripes sliding, and timing, how quickly they shift, is a shadow of the phase tree being disturbed. Most textbooks will talk about interference, path length, wavelength, frequency. Holophase says, you are already looking at phi. You just didn't know to call it by its name. Example, a GPS satellite. Your phone's GPS positioning depends on clocks in satellites high above the Earth. Those clocks tick at slightly different rates than clocks on the ground. To make the system work, we have to correct for speed, the satellites are moving fast, gravity, they are higher up where gravity is weaker. These differences are usually explained as time dilation and gravitational time shift. Holophase says, all that is really happening is this. Phi's rhythm, the holophase, is turning at slightly different rates in the satellite's region and on Earth's surface. Time, as shown by the clocks, is just the time screen's way of reporting that. Again, you are already looking at the tree's behavior. You just call it time differences instead of differences in phi's local rate. 6. Derivatives in everyday language. We've used the word derivatives a few times. Let's make that friendlier. You can think of derivatives as how something changes, and then how that change itself changes, and so on. Imagine you are cycling up a hill. Your height above sea level is like the base value, a bit like phi at a point. The slope of the hill, how steep it is like the first derivative, how quickly your height changes as you move forward. The curvature of the hill, whether it's getting steeper or flattening out, is like the second derivative. You feel these in your body. A gentle slope, not too hard. A slope that suddenly becomes steeper. Your legs burn more. A slope that eases off. Your legs relax. Now imagine the hill is not just in space, but in space and time. The slope changes during the day as the ground slowly shifts. The path itself bends and twists. This compound behavior is what higher derivatives capture. In our tree picture, the trunk says, here is the height, here is phi. The big branches say, here's the slope, first derivatives of phi in time and space. The smaller branches say, here's how that slope is changing, second derivatives, like curvature. Finer twigs would represent even higher levels, change of curvature, change of curvature, and so on. We don't need the technical language here. The important thing is, the whole tree captures not just what phi is, but how phi is changing, and how those changes are changing in every direction. Time, space, and motion are three organized ways of reading those changes. 7. A simple scientific gate. If the tree moves, the shadows must move. To keep this from floating off into pure philosophy, we need a very simple, very strict rule. Here it is. Whenever the underlying phase tree changes in a real, physical way, all three shadows, time, space, and motion, must respond in a consistent way. If you do something that clearly changes phi in some region and time measurements change, geometry measurements change, motion patterns change, and all three sets of changes can be understood as coming from one shift in the tree, then the holophase picture survives that test. But if you find a situation where phi changes, you can see this through interference or phase-sensitive experiments, yet time shows no consistent change, and geometry refuses to shift, or motion doesn't line up, and no careful reinterpretation can fix this, then the tree story is in trouble. The holophase model is not allowed to say, oh, the tree changed, but somehow the shadows didn't. The rule is, if the trunk bends, the branches and shadows must move. If they don't, your picture of the trunk is wrong. That is what makes this a scientific model, not just a pretty metaphor. 8. From expression to source, changing how we look. Now we can say clearly what this part of episode 5 is really about. Up to now, we've been focusing mainly on the expression of holophase. How phi looks when we call it time. How phi looks when we call it space. How phi looks when we call it motion. In this part, the job was to turn your attention from the expression to the source. From the universe is made of time, space, and moving stuff, towards the universe is structured by a phase tree, phi and its derivatives, and everything I call time, space, and motion are just three consistent ways of seeing that tree in action. It's a shift in attitude. Instead of saying, time flows differently here, you quietly ask, what is phi doing here to make clocks behave this way? Instead of saying, space is curved near massive bodies, you ask, how is phi laid out here so that distances and angles look like this? Instead of saying, that particle is moving, you ask, how is this feature of phi drifting through the field, and what are its derivatives? You start to see the world behind the world. The shadows don't disappear. We still measure time. We still measure distances. We still study motion. But now, in the back of your mind, a quiet second question is always running. What might phi be doing under all this? That question is the beginning of seeing the tree. A brief glimpse of what comes next. Before we close, I want to very gently set the stage for the next part of this episode. We won't go into it in depth here. That is for our next conversation. But we need one small seed planted. We have said, the tree is phi and its derivatives, the real skeleton. The three screens are time, space, and motion, the dimensional shadows. The whole universe is this tree, everywhere. In the next part of episode 5, we are going to do something audacious. We will use these three shadows, time, space, and motion, to infer the large-scale shape of the tree itself, from the tiniest quantum scales all the way to the cosmic web. Not shape like a balloon or a donut, but shape in a deeper sense. How fast does phi tend to tick at different scales? How tightly or loosely is phi usually packed in space at those scales? What kinds of motions, slow, fast, chaotic, smooth, are natural there? In other words, we will treat time, space, and motion as three measurement channels and use them to sketch the dimensional structure of the universe as a single, scale-organized phase tree. That next step is where Holophase begins to talk seriously about the quantum world as one kind of phi architecture, the human, biological, technological world as another band in phi's spectrum, the cosmic world as the slow, deep end of phi's rhythm. But all of that belongs to the next part. For now, this part had a simpler, quieter job to help you feel in your bones that time, space, and motion are not the ultimate ingredients. There are three shadows cast by one hidden tree. That tree, phi and its derivatives, is the real code underneath. Once you start to see that, even faintly, the universe becomes a different place. You are no longer just a creature moving through space and time. You are a pattern inside the living phase tree, watching its own shadows move across the walls, and slowly learning to turn around and look at the tree itself. That, my friend, is where the Holophase journey truly begins.